Can we start?
Yes, so good evening, everyone. I hope all of you are here and all of you can hear me. I'm audible. Can someone confirm?
Yeah, you are.
Okay. So in the last few sessions, we learned about supervised learning, unsupervised learning, and we applied different models and we apply it using different data sets. So a lot of you, uh, although applied it, but did you ever wonder why are we getting such accuracies like 60%, 70%? Some of you, okay, might have gotten 90% also. But how do we improve it? So today's session is based on importance of hyperparameter tuning. What is it? And how do we implement it using the various methods like grid search, random search, or Bayesian optimization? So today's session is being conducted by Ramya ma'am. So ma'am, without further ado, I'd like to hand it over to you.
It's good evening all. One second, I'll share my PPT. The slide is visible for all.
Yes, ma'am.
Okay, fine. Let's start. I'm Ramya Shan, a research scholar from CSC department under Dr. Pida Basapadi. So today our topic is hyperparameter tuning in machine learning. And today, one second, why it is not moving? Yeah. Today, mainly we are seeing four things. First one is what is hyperparameter and what is parameter, how they are different and what are the importance. And what is mean by hyperparameter tuning and why it is important, how it will affect the model performance. And last topic is what are the different techniques to perform the hyperparameter tuning. These are the four things today we are going to see. So the first part is parameters and hyperparameters. Parameters and hyperparameters, you already learned the different ML learning algorithms, right? Machine learning algorithms. For example, nearest neighbor, K nearest neighbor, support vector machine, MLP, logistic regression, decision tree, like that, different machine learning algorithms to perform classification or prediction. And these learning algorithms will have their own set of parameters and hyperparameters. And what is parameter and what is hyperparameter? Parameters are both are type of variables only, but the main difference is parameters are intrinsic to the model. Intrinsic to the model means that is inside to the model. I mean, those values of these variables are learned during the training time from your data set. From your data, the values are learned during training. Actually, these parameters are representing the relationship between the data. What are the relationship present in this data sample? And these parameters, after training, these parameters can be used for the prediction or classification or whatever the task. But coming to the hyperparameter, I'll give you the example later. First, I'll give you the definition, then we'll see in detail. Hyperparameters, here parameters are told it is learned from the data during training. But hyperparameters we cannot learn during training. That we need to set before training starts. Manually we need to set what are the values for the hyperparameters. And these hyperparameters will be used to determine the value for the parameters. And these hyperparameters can control the entire learning process. For example, you all know KNN, right? K nearest neighbor. When you are implementing K nearest neighbor or when you are training the model K nearest neighbor, you need to specify how many neighbors are you are considering. Number of neighbors. That number of neighbors you might have given 1, 200, 3000, like that. Any value you might have given, right? that value, number of neighbors, that is one of the hyperparameter. And this number of neighbor, we cannot learn from the data that we are setting before the training starts. And based on that data only, that value only, model is training and determining the parameters, model parameters. And if you are giving the proper number of neighbors, then your parameter value will be the best value, and that parameter, due to the best parameter value, the model can generalize well for the unseen data. And for example, when you are designing a neural network, how many layers you need, or in each layer, how many nodes you want. All these are comes under hyperparameters. But coming for parameters, that we cannot set, that we are, it always start with some random value. When we are starting the training, the parameters will be some random value, and during the training, that value will be learned from the data. Based on the relationship of the data, that value will be learned. For example, weight and bias in the neural network, or coefficients in the linear regression, or support vectors in the support vector machine model. These are the parameters. So the main difference of parameters and hyperparameters are, hyperparameters value cannot learn from the data, that we need to set before training. And that value will help us to learn the parameters or determine the parameters. This is the main difference of parameters and hyperparameters. Then why are hyperparameters are important? Hyperparameters, why it is important is, it can influence the model performance. I mean, if you are perfectly picking, or if you are correctly picking the hyperparameter, then you will be able to determine the correct model parameter for the model. If you are able to get the correct parameter, then that model will generalize well for the unseen data. If you are poorly choosing the hyperparameter, for example, randomly you select a number of neighbors as 3. We don't know whether 3 is the proper value for us a number of neighbor. If it is proper value, then your model parameter will be learned properly, and that model will be used for the classification. If the 3 number of neighbors are not 3, and that value is say very poor selection, then the model will leads to a underfitting or overfitting. So this hyperparameter, the perfect pick of hyperparameter value, can optimize your model accuracy, and that will lead to the generalization. Hope you understood why our hyperparameters are important. We'll see the examples also. And let us see some hyperparameters in different ML algorithms. For example, first one is k-nearest neighbor. K-nearest neighbor is one of the machine learning algorithm. The main three hyperparameters are number of neighbors, weight function, and distance metrics. Number of, I'll show you one example. 1 second. Screen is visible, right?
Yes, ma'am.
Okay, here you can see. Program will see in detail later. Just see this. Here the selected part you see. This is the KNN algorithm, design of KNN algorithm. Here I have taken 3 hyperparameters. One is n underscore neighbors, that is number of neighbors. The second hyperparameter is weight. Third one is the metric. So number of neighbors, I have given some values, 3, 9, 37, 69, 101. I don't know which is the correct one. So we can given some values there. And weight is the another hyperparameter that will, there are 2 different values I have taken for weight, uniform and distance. Uniform means each and every neighbors will get the equal importance. If I take distance as the weight, then which all are the neighbors are very closer, they will get the more influence. And the metrics is how to calculate the distance between two data points. There are three different ways: Minkowski, Euclidean, Manhattan. So these three are the hyperparameters. So we don't know what is the correct weight value, whether it is a uniform value or a distance. What is the correct metric? We don't know. But it can be Minkowski, it can be Euclidean, it can be Manhattan. Number of neighbors also, it can be any integer. We don't know what is the correct number of neighbors for this particular data. So we need to pick that hyperparameter value properly and we need to set it before training the model. If you are picking the wrong value, then your model will not generalize well. So these are three example for k nearest neighbor. One second, I'll just share my screen itself otherwise. Okay, the next algorithm is decision tree. Like k nearest neighbor, we have for decision trees also we have two different hyperparameters I have kept here. One is max depth, another one is a minimal sample split. Max depth indicate what is the maximum depth of the tree. That can be 3, 4, 5, 6, even 100. We don't know, right? So that we need to set before training the data. So that is one hyperparameter. These values cannot be learned from the data. That we need to set that, and these values will help to learn the parameter values properly. Then the second hyperparameter for the decision tree is minimum sample split. How many minimum samples required to split the node? It can be 2, 3, 4, anything. Like that, random forest also have hyperparameters. Two examples are number of trees and max depth. Number of trees indicate how many number of trees are there for the random forest and what is the maximum depth of each and every tree. The same way, SVM and neural networks also have some hyperparameters. For example, kernel type and C value for SVM, number of layers, each number of layer, how many nodes are there, and what is the learning rate, what is the batch size. These all are hyperparameters. And this hyperparameter, you have to pick proper hyperparameter that will help you to learn the parameter properly. If your parameters are learned properly, then model will generalize well for the unseen data. We can say example for all these things after this theory part. Then how do we pick the for example here KNN number of neighbors can be any integer, right? How do we select? Or there are two different metric mechanisms, three different metric mechanisms is there. Euclidean distance is there, Minkowski is there. So which one is the correct one? Or weighting mechanism. There is uniform weight or distance is there. Which one is the correct? So process of selecting the best hyperparameter for a model is known as hyperparameter tuning. We have a hyperparameter space. From that space, we are picking the best hyperparameter, best number of neighbor we are picking. What is the best metric for this particular data? What is the best weight for this particular data? What is the best maximum depth for this particular data? So how to the process of selecting the best hyperparameter is known as the hyperparameter tuning. So this why we need to do the tuning? That will help to improve the performance of the model, right? Improve the performance of the model means it will generalize on the unseen data. And how do we perform this? How do we pick the best weight? There are n number of integers. From that, how do we pick the best number of neighbors? There are some techniques. The main four important techniques are: first one is manual search, second one is grid search, third one is random search, fourth one is the Bayesian optimization. So manual search, for example, you have a data set. You need to perform KNN classification. First, you need to identify what is the number of neighbor for your data. That can be any integer. So to pick the best one, here I'm doing some tuning here, hyperparameter tuning. And my technique is manual search. I don't want any other search. I'll be doing the manual search. So how do we do the manual search? I'll pick some values. One, first I'll pick one. I'll train my model. I'll mark my accuracy. Then I'll pick a 10. I'll train model. I'll mark my accuracy. Then I'll pick 15, 20, 100, 1000. Like that, different values I'll set. For each and every values, I'll train the model. I'll find out the accuracy. Then which one is giving the highest accuracy? That will be my best number of neighbor. But the problem is, it is a very time consuming process, right? And how many line of codes you need to write? You have to write the code for number of neighbors as 1, the number of neighbors as 2, number of neighbors as 3. You have to train the model for each and everything, right? You have to do the manually. We need to find out which one is the best number of neighbor. So that is the problem with the manual search. We'll see one example here. Yeah. See, here my data set is, this is one character recognition, handwritten character recognition data set. I have used one feature extraction method called the DCT to extract the features. And this these are my features. I have 195 features, and the last one is the label. I hope you know all these features, labels and all, right? Here, last column is the label. So I have taken last column as the Y, my label, and all other columns are my feature set. So except the last column, all other column will take us X. So I have X and Y. I'm going to perform KNN model training on this data. And before performing KNN training, I need to pick best hyperparameters. And to pick best hyperparameters, I'll be using manual search here. For that, first I have split the data into train and test. I used 20% for test, 80% for the train. This is the train test splitter. Then I used some scaling technique also to scale my data. I use the min-max scaler. And here, this is, our focus is here. I need to perform KNN, right? And KNN, there are 3 hyperparameters I need to consider. One is the number of neighbor, one is the weight, one is the metric. You can see number of neighbor, weight, metric. Number of neighbors can be any integer value. Weight can be, there are 2 values for weight. It can be uniform or it can be distance. Metrics, there are 3 values. It can be Minkowski, Euclidean, and Manhattan distance. And I don't know which one is which combination is the best one. I don't know. So I have to pick the best combination. For that, I'm doing the manual search. So for that, I have defined different set of hyperparameters. My first hyperparameter, I have taken 3 neighbor, weight is uniform, and metric is Minkowski metric. Second set, I used 9 neighbors, distance as the weight, metrics as the Euclidean. The same way, third parameter, fourth one, and fifth. 5 hyperparameter set I have designed. Then I will be training 5 KNN models. First model is this one. This model will be using the first set of hyperparameter. This is my second model. Second model will be using the second set of hyperparameter. Like this is the fifth model. Fifth model will be using the fifth set of hyperparameter. I initialize the model with the different hyperparameters, and I will be using dot fit method to train the model. First model, second model, third, fourth, fifth. All models are training. All are KNN models only. The difference are These KNN models will be using different hyperparameter values. After train the model, I'll be using the trained model to predict the test values. Here I'll be doing the prediction to test prediction. Then I'll calculate the accuracy. Let us see what is the accuracy here. See, my data set is same data set, right? Character, handwritten character recognition, DCT data feature set is my data set. And I'll be using the same model. Model is the KNN, but 5 different KNN I used. What is the difference is hyperparameters combinations are different. First case I got 0.769 as the accuracy. Second case I got 0.751 as the accuracy. Then 0.658, 0.619, 0.558. These are the different accuracy I got. From this I'll understand the first one. From this the highest accuracy is the first model, right? So first model has, where it went? First model hyperparameters are number of neighbors as 3. Weight is the uniform. Metric is the Minkowski matrix. So out of this 5 combination, first combination is the best one. But here the problem is there are n number of combinations, right? Is it possible to do all combinations here manually? It is difficult. But if your data set is very small, then you can go for the manual search like this. Here I have tried a 5 different hyperparameter set combination. From that I got it. My first parameter set is the best one from the accuracy. This is called a manual search. Hope you understood manual search. Any doubt? Shall I go to the next method, grid search? Hope you are understanding. I'm continuing. The second search to pick the or second technique to pick the best hyperparameter is grid search method. Grid search method, first we need to set the hyperparameter values. I mean, you can mention these, consider these higher number of neighbors, consider these weight values, consider this metric. Then algorithm automatically will take all combination of the given hyperparameter values and it will compute which one gives the highest result. We'll show you the example here. Yeah, this is the example for grid search CV. We have a library from sklearn. I have imported grid search CV, and we can use this grid search CV to tune the hyperparameters. And here, first I'll be define my hyperparameter grid. This is called a hyperparameter grid. Here KNN is the example. 3 hyperparameters are there. Number of neighbors, weights, metric. Number of neighbors, I mentioned some values. You can mention any number of values. Even you can mention the range also, 1 to 100 or 1 to 1000. Like that range also you can mention. Here for execution easiness, I have mentioned 5 values: 3, 9, 37, 69, 101. Weight I mentioned 2 values, uniform distance, and metrics I mentioned 3 values: Minkowski, Euclidean, Manhattan. This grid search, how they are working is they'll take all combination. For example, first they'll pick a neighbor 3, then they'll pick uniform, then they'll pick Minkowski. So that combination they'll work. Then the next iteration they'll pick neighbors as 3, weight is uniform, and metric as the Euclidean. Like that they'll pick all combinations. So how many combination will get here? Number of neighbors are 5, weights are 2, and metric is 3. So almost 5 into 2, 10, 300 combinations they'll pick. All possible combination using these 3 hyperparameters, or what are the all possible combination? All combination they'll pick, and they'll perform your cross validation. I hope you have already learned cross validation. So for example, first they are picking the first combination. I'll write here for your understanding. I'll write here. Combination 1 is neighbor is 3, uniform weight, and Minkowski is the first combination. Second combination will be 3, weight is the uniform itself, and distance they'll change to Euclidean. Like that, all combinations they'll pick. Then for each and every combination, for example, first combination, for every combination, they'll perform the 5-fold cross validation. Here, what is 5-fold cross validation? Your entire data set is divided into 5 parts, and they'll do 5 iteration. In each and every iteration, the one part will be taken as the test value. So first combination will work based on the 5-fold cross validation, and they'll get the accuracy. Second combination also evaluated using 5-fold cross validation, accuracy is calculated. Like that, for all combination, they evaluated across 5-fold cross validation or 10-fold, any n-fold cross validation, and compute the accuracy. Here you can see here param grid is the your grid space. This is our grid space. This is our grid space. And CV is equal to 5, you can give 5, 10, any value you can give. That will, here 5 means 5-fold cross validation is happening. And your the best model is picked based on the accuracy value. And here I'm performing the KNN model classification, right? That's why here I kept a KNN. And model is training. Model is training. Grid search.fit means for each combination, model is trained. Then each combination value is saved, and I'll be printing here. This is the result. Here, I'll show it here. It will be easy for you. 1 second. One second. Here you can see, I'll show you the result. Here. See, this is the first combination. This is the first combination. They have taken metric as Minkowski, number of neighbors as 3, weight as the uniform. For that, they got accuracy as 0.737602. Second combination is the, here metric same, number of neighbors also same, and weight is, they instead of uniform, they kept a distance. Accuracy they got as 0.746. For the third combination, they changed the number of neighbors also. Here number of neighbors is 9 and weight is the uniform. Like that, for all possible combinations, they'll try, and here accuracy has been calculated for all combination using the cross validation, across cross validation. And from this accuracy, best hyperparameter combination, best accuracy is the 0.753, and 0.753 we achieved using Manhattan metric, number of neighbors as 3 and distance as the weight. So if you pick something, for example, here this is the 19th one now. 19th one is the 0.54. So 19th one you can see. 19th one is, this is the combination. For example, if you are not performing tuning, randomly you picked a metric as Euclidean, number of neighbors as 101, weight is distance. Then your accuracy will be 0.54. It is very less accuracy for the classification task right here. So, but if you pick the best one here, it is the Manhattan metric. The number of neighbors as 3, weight is the distance. Then that 0.54 changed to 0.753. So this is the grid search method. This is one of the techniques for to perform tuning. Grid search, the previous one was the manual search. We need to perform, we need to, as a practitioner or data scientist has to write a code for each and every combination. Here we have to just given the space. This is my hyperparameter space. From this, all combination has been selected automatically using the grid search CV algorithm. The next method is the random search. Random search is same as grid search, but the difference is here. I'll show you the example. This is the example for random search. Here we are using the library randomized search CV from sklearn model. Here, like grid search, you need to define your parameter space. For example, number of neighbors, the same number of neighbors, whatever we have given in the grid search, same number of neighbors we give here. Weight also the same, uniform and distance. Metric is those 3 metrics. But how it is different from grid search CV is, grid search CV will pick all possible combinations of these values. But random search CV will not pick all combinations. They'll pick some random values. It will not work for all combination. They'll pick some from this given values. They'll pick some random values. Then perform the training. Here, randomized CV is the library we used and KNN is the model. And parameters is, these are the our hyperparameter space. From those, here I have mentioned n iteration 5. 5 means they'll not pick all combination. They'll pick any 5 combinations. You can mention any number of iteration there. If I mention 10 here, from these they'll pick 10 combination, not all combinations. Then this also work using evaluated using cross validation. I mentioned 5. If you can use a 10 or any values. And I'll be picking the best model or best hyperparameter based on the accuracy. And here, all other things are same. Only thing is the number of iteration. Here we need to mention number of iteration because we don't need to perform all combinations. We just want to perform number of given number of iteration combinations. Here I mentioned 5. So randomized search CV will pick 5 different combinations and perform. Here, these are the 5 they have picked. They taken number of neighbors are 69, weight is distance, and metric is Manhattan, and number of neighbors is 37, same weight and metric is Euclidean. Like that, they picked 5. They didn't pick all the combination, only 5. But in the case of grid search CV, they picked all the combinations. But here, how many iterations I mentioned, only those combinations will pick. And these are the accuracies. From this, the best accuracy is this one, 0.731 is the best accuracy. And this is the, from this particular combination gave the best accuracy. This particular combination gave the best accuracy. So the difference of grid search and randomized search is grid search will perform all combination. Random search will not perform all combinations. So grid search will take more time for the training because if you have 30 combination, all 30 combinations. If you have 200 combination, all 200 combinations, 200 models they need to train. Here, we don't want to train all the combinations. So it will computational time will be less. And here, always we cannot assure the good result. Sometimes they will stop at the local minima. We don't know whether they picked 5. Those 5 will be giving the best accuracy, not sure. For example, here we got 0.731 as the best accuracy. In the previous case, the same data set 0.753. 0.753 was the best accuracy. Same data set, same KNN, only the tuning was different. Tuning technique was different. Accuracy is 73. Previous case 0.75. So this is randomized model, randomized research. And the last one is the Bayesian optimization. Bayesian optimization is the main difference of Bayesian optimization and the previous one is Bayesian optimization will pick the hyperparameters based on their past experiments or past past evaluation result. And they'll be using some probabilistic model to find the best hyperparameter. For example, everything is same, but they're working. See, here I used a base search CV from SKOPT, and this is the same parameter spacer, same number of neighbors I kept, same weight I kept, same metric. But the how do they tune the values? How do they pick the values is different. Here the algorithm used is Bayesian optimization. Basically, how do they work is uh, first some iteration they'll pick randomly. From this hyperparameter combination, they'll pick randomly. First some 2-3 combination they'll pick randomly, and they'll learn how those 3 iterations or how these 5 iterations are working. And from that, they'll be making one probabilistic model. And that probabilistic model will be able to give you the best value for the next cases. So first 2-3 iterations will be picked randomly, and from that they'll be learning, and that learned experience or past experience will be used to pick the remaining combinations. So here also only 5 iterations I mentioned. You can, if you want, you can mention 15 or 20. The main difference of this one and the previous one is previous one, all 5 are picked randomly. Here, all 5 are not picked randomly. 1 or 2 are picked randomly. From that, they'll be learning and they will be making one probabilistic model. And that probabilistic model will be used to pick the remaining or subsequent values, combinations. That is the difference of Bayesian search CV and randomized CV. Here, this is the 5 combinations they picked. Here, first 1 or 2 will be the random picking. From that, they learned one, they created one probabilistic model. Then they used that probabilistic model to pick the remaining subsequent combinations. And here we got, these are the accuracy value for the given 5 combinations. And the best one is the 0.753. Best accuracy is from this. Best accuracy is the 0.753. The third one. This case is giving the best accuracy. These are the different techniques used for hyperparameter tuning. From this experiment, you will understand the importance of tuning. See, if I'm not doing the tuning, and if I randomly pick my metrics as Euclidean, number of neighbors randomly I picked as 69, and weight is the distance, then I'll be getting accuracy only 58%. But if I do the tuning, and if from the tuning, I'll be getting the best hyperparameter value. Using that best parameter value, my model is trained. So model will be learning the model parameters properly. Then using that model parameters, we can that indicate if the model parameters are learned properly means your model will be able to generalize well for the unseen data. So this is the example for KNN. Same thing we can do for any models. Here I have one more example. I'll show you. Yeah. Here I used different models. Here you can see MLP. MLP, this one hyperparameter is the hidden layer sizes and one is the activation. Hidden layer sizes means how many hidden layers are there and what are the number of nodes in the hidden layers. It can be any number of hidden layers, right? And I can be 2 hidden layer, 3 hidden layer, 1 hidden layer, 100 hidden layer, and each hidden layer will be having any number of nodes. So here I given 3 values. 50 indicate I have only one hidden layer. That hidden layer has 50 nodes. This indicate I have again only one hidden layer. It has 100 nodes. This indicate I have two hidden layers. In that, both the hidden layers will be having same number of nodes. And activation can be ReLU or tarnish. So from this, they'll pick how many hidden layers are the best one and what is the activation. We'll see what is the result here. See, here, when I trained my data using MLP, and my hyperparameters are hidden layers and activation is ReLU and tarnish. Tarnish or which one I gave? Tarnish. When I do the grid search CV, it is telling ReLU is the best activation than tarnish, and only one hidden layer is enough. In that, there are two options I given for one hidden layer. One is hidden layer with 50 node, one is hidden layer with 100 node. And a tuning technique is telling one hidden layer with 100 nodes is the best combination to get the accuracy of 77.76. Like this, you can set the parameter for random forest. Here, random forest number of estimators. That means number of decision trees inside the random forest. It can be 50, 100, 200. And what is the maximum depth of each tree? I kept a 5, 10 or none. None means it is growing full grown. Each tree is growing full. Decision tree. That next algorithm I kept is decision tree. Maximum depth, it can be 5, can be 10 or grown it full way. Minimum samples to split in each node, a minimum either when we have 2 samples or 10 minimum samples. Like this logistic regression and SVM, they also have some hyperparameters. One is C, one is penalty. SVM also C is there, but both the C's are different because their mathematical foundation is different. Here, kernel is one hyperparameter. Kernel value can be linear and RBF. These are the param grids I used. My hyperparameter space. These are my hyperparameter spaces. And when I train MLP, this combination of MLP gives the highest accuracy. This combination of random forest is giving the highest accuracy. This combination of decision tree is giving the highest accuracy. Like this, SVM and logistic regression. I think from this experiments, you will understand the importance of hyperparameter tuning. You should not pick the random values. Always before training, you have to tune your hyperparameters using grid search, randomized search, or Bayesian optimization or manual search. Depends on the data set size. If your data set size is very small, you can go for the grid search because it won't take much. Grid search is all combination, but as your data set is small, it won't take much time. If your data set size is very big, go for randomized search or Bayesian optimization. You have to use any particular techniques to pick the value to your hyperparameter, then use that hyperparameter to train your model. From thus, we'll understand these models are not learned from the data. As a practitioner or data scientist, we only have to set these values. We cannot learn these values from the data itself. Data is learning using these values, not these values are learned using the data. Okay. If you are picking the proper value, your model will learn perfectly and it will generalize well. If you are not picking the perfect value or if you are doing the very poor selection, model will lead to underfit or overfit. The main difference of randomized search and Bayesian optimization is randomized search will pick how many number of iterations are mentioned, that many random pick they'll do. But Bayesian optimization is not doing all random pick. First 2-3 iteration they'll do the random pick. From that they'll make one probabilistic model. That probabilistic model will be used to pick the subsequent combinations. So this is learned from the past experiments. And this is the conclusion. Hyperparameter tuning is crucial for ML performance. Otherwise, it will lead to the overfit or underfit. I mean, your model will not generalize well. Different methods balance accuracy vs computation. When you are picking, picking the techniques, You have to see the computation time also. Your data set is very big, then you should not search the grid search, because grid search will pick all combination. If your data set is very big, then all combination means it will take so much time. So that you have to pick into like you have to do it properly, which techniques you want. That's all. Thank you. Any doubt?
Anyone, any doubts? You can unmute your mic or you can type in chat. Okay. I think there is no doubts.
Okay.
Thank you,
So
ma'am,
do I
for
need to
this. Yes, ma'am.
do I need to share the PPT and the program?
Sure, ma'am. You can share it on chat or share it to me personally. We'll upload it on our website.
Okay. I'll share you. Okay. I'll download
Yes,
and
ma'am.
share to you. Okay.
Thank you.
Thank you.
Guys, this topic is very important. Whenever you're making a project, it is very important to know how you fine tune the model according to your data. So I hope you go through the resources once again or the recorded lectures and understand hyperparameter tuning. If you have any doubt, please feel free to reach out to us. There's a doubt group. All our numbers are there in the group. You can message us. You can reach out to ma'am. Also, does anyone have any doubts regarding the assignments or previous sessions? Okay, I think no one has any doubts. So we'll conclude today's session. Thank you everyone for joining. Thank you so much, ma'am, for such an informative session. Really loved
Thank
it.
you.
Thank you,
Thank
ma'am.
you very much. Thank you. Shall I leave?
Yes, ma'am. Thank you, ma'am.
Thank you.
All of you can leave. Thank you.